Hello everyone. Today we are going to perform the practical for the applied science chemistry. All informations are followed by the as per the laboratory manual. This is the book we are using to perform the practicals and we are going to note it down the readings in this book. Experiment number 2, that is the practical number 2, to determination of percentage of copper in a ore. What is the ore? Means it is a naturally occurring substance in which metal is having in a high percentage. So we require copper for the different purposes, for making a wire, for making utensils, for making instruments. We require the copper metal as it is a very good conductor of electricity. So what we are going to do? We are going to find out how much copper is present in a given ore sample. If it is contain higher percentage of copper, then only we are going to use that ore for the extraction purpose. So first we have to know how much copper is present in the ore. Practical outcomes are, program outcomes are, we are required the basic knowledge. Experiment and practice. We are going to perform it to get a perfect reading. We are going to perform individually as well as in a team. What is the minimum theoretical background? Before performing this practical, you must have theoretical knowledge. What is meaning of that? Copper is important ore for the industry. As it is a good conductor of electricity, it is hard, corrosion resistance, durable and machinable. When copper is dissolved in a HNO3, so where we are going to dissolve the ore in a HNO3, copper present in the solution is transferred in the form of cupric ion, and along with that we are going to add a sulfuric acid, and so copper is converted into the copper sulfate. As a copper metal, it is insoluble. Copper metal will not dissolve in a water. So we are converting copper into the copper sulfate, which is a soluble form. So copper sulfate solution when treated with a Ki, that is a potassium iodide at a pH of 4 to 5.5. Cupric iodide is formed and cupric iodide is unstable. It decomposes to the cuprous iodide and liberating iodine gas. And that liberating iodine gas we are titrating against sodium thiosulfate using a starch indicator. Means what? We are not able to find out the copper ion directly. So what we are going to do? We are going to treat with a Ki. So what happened? The Ki is going to release the iodine. How much? As per the amount of copper, it is going to release the iodine, and we are going to determine how much iodine is liberated. If 50 gram of iodine is liberated, we will say that 50 gram of the copper is present. So first we are going to treat copper ore with a nitric acid and a H2SO4. It is converted to the CuSO4, that is a water soluble. Then we are going to treat with a potassium iodide, which is going to release equivalent amount of iodine, and that is determined by the how much iodine is liberated, that determined by using a sodium thiosulfate. So what is the burette solution? Sodium thiosulfate, Na2S2O3. In a conical flask, we are going to take a sample solution, that is a copper sulfate solution, and we are going to treat with a Ki. These are the requirements for this practical. Burette, round bottom flask, wire gauge, conical flask, iodometric flask, pipette or the measuring cylinder, volumetric flask, sample chemicals like the ore sample, Ki, thiosulfate, nitric acid, H2SO4, and a starch as an indicator. When we are performing these practicals in a laboratory, we are going to follow some precautions. What are that? We have to wash all glass apparatus thoroughly with a distilled water before use. We have to rinse burette. Glassware should be properly washed so no impurities involved. We are going to remove the air bubble through the burette. We are putting the conical flask on the white tiles so we can observe it. And we are going to add solution from the burette dropwise. Here I given a link for the video. How we are going to perform? Let's see. This is your copper sulfate solution. Means what? Copper ore solution we are converted into the copper sulfate. So initially it is a blue color. So in this we are going to add sodium hydroxide. Initially it is a transparent one. So when we are adding sodium hydroxide, it will form a precipitate. Precipitate means it is going to form a turbidity. And the turbidity is dissolved by adding a acetic acid dropwise. Again it will become a clear solution. Then we are adding the Ki. So when we are adding a Ki, that blue color solution is turns to the brown color as the iodine is liberated. This is your initial solution. This is your brown color solution. In this brown color solution, we are going to add a sodium thiosulfate. Till what? It become light yellow. Till it become light yellow. Then after we are going to add a starch indicator. Starch, when we are adding a starch indicator, the solution turns dark blue. Again we are going to add sodium thiosulfate from the burette till it become clearless. And when that become clear, colorless, it is called as a end point. We are going to stop adding sodium thiosulfate. Burette से sodium thiosulfate add करना बंद कर देना है. So first we have to take a 10 ml of sample, that is a bluish color. We are going to add 212 drops of NaOH till particles are formed, that is a precipitate is formed. Then we are going to add acetic acid to dissolve the PPT plus 10 ml of Ki. When we are adding a Ki, solution is become brown. We are going to continue add sodium thiosulfate till it become light yellow. After that we are going to add a starch indicator. The solution turns dark blue. This is the light yellow color. When we are adding an indicator, it become black, blue, dark blue. Still we are going to add thiosulfate till it become clear, transparent. That is called as a end point. Indicator is starch, end point is blue to colorless. We are going to perform this procedure 3 times and we are going to note down 3 readings. For calculation, we will take an average of these 3 readings. This is the calculation part. When we are taking a VmL of thiosulfate, we will get 0.078 gram of copper. So when we are taking 10 ml of sample solution, we will get 0.07 of copper. If we take 100 ml, we will get 0.78 gram of copper. And 100 ml is obtained from the 1 gram of ore sample. So if the 100 gram of ore sample is there, 78 gram of copper is present. So result is percentage of copper in ore is 78.105%. These are the practically related questions. We are going to solve this by using the procedure followed. Thank you class. Thank you so much for your attention.